Hello friends, here in this video we will see a problem on Macaulay's method, which is also called as double integration method. Here is the question. A simply supported beam of length capital L carries 2-point loads as shown in figure below. The diagram is given to us. We have to find the maximum slope and deflection, and for this condition we are going to use the Macaulay's method to solve the problem. Now, for this beam which is given, as I can see, here it is supported at A and B respectively. These are called as simply supports. The load is acting at point C at a distance L by 4 from A and at point D, which is at L by 4 from B. So the loads are located at equal distance from A and B. So this beam is a symmetric beam, having load value as same, and even the distances from the supports are same. So it is considered as a symmetric beam, and for such a beam we need to calculate where will be the maximum slope and deflection. So the first step in such problems should be to get the values of support reactions. Support reactions, that is the reaction at A, and how much is the reaction at B because of the loading, that we have to find out. So here I'll say that in the solution part, since the given beam is symmetric, therefore the total load acting on the beam will be shared equally by each of the supports. So here we have, therefore total load is equal to W plus W, that becomes 2W. Hence I can say that this 2W will be shared equally. So RA is equal to RB, that is reaction at A is equal to reaction at B. That will be equal to 2W by 2, because the load is shared equally, it is half. So 2W by 2, 2W by 2. So finally when I cancel 2 from here, so therefore the reaction at A and reaction at B comes out to be W. So we have found out the support reactions. Now the next thing would be, I'll draw the diagram again. Here we have A and B as the simple supports, then points C and D. Distances are also given. L by 4 from both the sides. At the central location, the distance is L by 2 and the total length is capital L. And now since the load values were given, we have found out the reaction. At A it is W, and at B also the reaction is W. Now to solve it by using Macaulay's method, the first thing is we should consider a section on the beam which would be called as section XX and at a distance X. So I'll say that now consider a section XX on the beam at a distance small x from, I'll consider point A, that is from left hand side. So I'll take the section XX located at distance x from point A, because while solving Macaulay's method we have to take a section far away from point A and it should be close to point B. So here I have taken the section x, which xx, which is at distance x from point A, far away from A and close to point B. Such should be the location of the section. The next thing would be, we will be taking moments at this section, which is xx. So I'll say that therefore taking moments at section xx. Here while taking the moment, clockwise moment will be treated as positive and anti-clockwise moment will be treated as negative. So taking moments at xx, that would be called as m suffix xx is equal to, it is given by ei d square y by dx square. That is the equation of the moment, is equal to, now I'll take the moment at the section starting with RA. First we have RA. Now this produces a clockwise moment, so plus RA into, now the distance is RA into x. So here I have the distance as x. So the moment is RA into x. Next this W will produce anti-clockwise moment. So minus W into, now I want the distance between this load W and section XX. So it will be x minus L by 4. That is the total distance from W up till the section. That is, I want the distance from this load up to the section, this distance, and it is x minus L by 4. So here we have minus W into x minus L by 4. Then we have another load W and its distance is x minus L by 4 plus L by 2. That comes out to be L by 6. So here we have x minus L by 6 minus W into x minus L by 6, because if I add L by 4 plus L by 2, that gives me 2L plus 4L by 8. So it becomes 6L by 8. This will be 2L plus 4, yes, by 8. Then we have this as, this would come out to be, actually it is 3 by 4L, yes. So this will be, when I add them, that comes out to be 3L by 4. So instead of L by 6, here we have 3L by 4, this distance. So this is x minus 3L by 4. I have shown how the value comes out. Now, so instead of L by 6, we have minus 3L by 4, because this distance is L by 4. L by 4 plus L by 2, that comes out to be 3L by 4. Now, after reaching up till this stage, that is, I have taken the moments. Now since we are solving it by Macaulay's method, also called as double integration method, we need to equate this. So therefore, integrating once, we get, now if I am integrating this equation once, I'll get this as, EI will remain as it is. Next, d square y by dx square, that will be dy by dx. RA into x, so RA will remain as it is. X will become x square by 2, and here I'll have a constant because I am integrating here. So plus C1, this is the first term, then minus W, it is x minus L by 4, so that will become x minus L by 4 square divided by 2, and for this term minus W into x minus 3L by 4, so x minus 3L by 4 square divided by 2. So this is the result of the first integration. So now here I'll put the value of RA was W, so therefore I have EI dy by dx is equal to W by 2, I'll write it as it is, and here I have x square plus C1, this is the first term, minus the next things I'll write them as it is. Now, so after the first integration I am getting this equation. Next I'll say that since it is a double integration method, so integrating once again we get, this will be EI, instead of dy by dx, the integration of dy by dx, it will be y is equal to W by 2, I will keep it as it is, x square, that will become x cube by 3 plus C1, so integration of plus C1 with respect to dx, that will be C1 into x, then I am integrating for the second time, so I'll have another constant called as C2, then minus W by 2, here we have x minus L by 4 square, so after integration it becomes cube divided by 3, so this 3 will be here in the denominator. Next minus W by 2 into x minus 3L by 4, this will be cube, again integration of x square, that is x cube divided by 3, so 3 will be multiplied in the denominator. So therefore we have EI into y is equal to W by 6 x cube plus C1x plus C2 minus W by 6 x minus L by 4 cube minus W by 6 x minus 3L by 4 cube. So now this equation is the slope equation, is the deflection equation, and previously EI dy by dx, this was the slope equation, so I'll keep this as equation 1 and here is equation 2. Now after getting equation first and equation second, we need to know the values of constant C1 and C2, because once we have the values of C1 and C2, then we will get the complete equation of deflection and slope, and then we can find the remaining unknown values. So now I'll say that to calculate the values of constants C1 and C2, we need to apply boundary conditions. To calculate C1, C2, we need to apply the boundary conditions. Now what are those boundary conditions? When we have the diagram of this simply supported beam, I can say that at point A the deflection is 0 because it is supported here. So I'll say that the first thing is, the first boundary condition, at distance x is equal to 0, the deflection y is 0. So therefore put this boundary condition in equation number second, that is the deflection equation we have got. So here I'll put the values. First is at x is equal to 0, y is 0. So if y is 0, left hand side becomes 0 is equal to, on the right hand side x is 0, so this first term becomes 0 plus c1 into x, x is 0, plus c2, we have to write it only up till here, so therefore c2 becomes 0. Now I'll apply the second boundary condition, that is at x is equal to, when x is equal to capital L, here also the deflection y is 0. So at x is equal to L, capital L, y is equal to 0. So therefore put this boundary condition in equation number second. So we have this left hand side will be 0 because y is 0. Next, on the right hand side I have w by 6, which is as it is. Instead of x, I'll put the value as capital L, so capital L cube. Then plus c1 is as it is, x is L, plus c2 is 0, then minus w by 6. Here we have x, so instead of that I'll put L, L minus L by 4 cube minus w by 6, x is L minus 3L by 4 cube. So I need to simplify this to get the answer of C1. Plus C1 into L minus W by 6. Now when I am simplifying this complete bracket, here in the denominator it is 1. So this cross multiplication will be 4L minus L, which is 3L by 4. So 3L by 4 is cube. Here we have to cube that term. So the cube of 3L by 4, that will be 27 L cube upon 64. So I'll write directly 27 L cube upon 64 minus W by 6. Here this will be 4L minus 3L, which is L upon 4, so L upon 4 and cube, so this is L cube by 64, so into L cube by 64. So on further simplification, now minus, here 6 into 64 in the denominator, that comes out to be 384. So minus W 27 WL cube upon 384, then minus WL cube upon again 6 into 64 in the denominator, that is 384. Now I want the value of C1, so I'll keep C1 on one side. So therefore C1 into L will be on one side. Next, WL cube by 6, send it onto the other side. So minus WL cube by 6. 27 by 384, that is negative. If I send it onto the other side, it becomes positive. This term is negative, send it onto the other side, so positive. Then I have to again simplify this. So C1 into L, this term would be, here taking the LCM, that would be 384, and in 6 here I have to multiply it by 64 to make it 384. So 64 gets multiplied in the numerator as well. So minus 64 WL cube plus 27 WL cube plus WL cube. So finally here if I am simplifying this, I'll get C1 into L as this is minus 36 WL cube upon 384. So here this will get cancelled out, and here I have, first I'll cancel it with 3, so here I have 3 12, and this will be minus 12 by 128, and again if I divide this, then so here I have, therefore after the cancellation, C1 into L is equal to minus 3 by 32 WL cube. So from both the sides what will happen is L and L will get cancelled, so I have C1 is equal to minus 3 WL square by L square by 32. So this is the value of C1 which I am getting. So now after getting C1, now I'll put C1 value in equation number 1. So I will get the slope equation. Here I'll say that therefore put C1 in equation number 1. So we have in equation 1 EI dy by dx is equal to W by 2 x square. So W by 2 x square. Now it is plus C1, and C1 was minus 3 WL square by 32, minus 3 WL square by 32. This is the first term. Next I'll just copy these terms as it is. So minus W by 2 into x minus L by 4 square minus W by 2 x minus 3L by 4 whole square. So here is the equation, which is equation number 3rd. Therefore in equation 3rd, equation number 3 is called as slope equation, and from this equation we can calculate slope at any given distance x on the beam. So we can find out slope from this equation, which is equation number 3rd, at any given location. Now the question was, after getting the slope equation, here we have to find out the maximum slope and deflection. So first for maximum slope, since we have the beam diagram, now where will be maximum slope? First, when the load is acting, the beam will deflect in this manner. So the slope is maximum for a simply supported beam at the supports, that is at A and B, the slope is maximum. So I'll say that therefore maximum slope will for a simply supported beam will be at supports A and B. So now I'll keep x is equal to 0 because at A we will get the value of slope. So therefore put x is equal to 0 in equation number 3rd, because this is the slope equation. So when I keep the values, therefore now this EI here, it is getting multiplied. I'll shift it into the denominator on the right hand side. So we have dy by dx on one side. So therefore dy by dx, it is nothing but the slope at A, and it is equal to 1 upon EI. I'm shifting this EI here and this complete term. Now I'll put the value as x is equal to 0. So if I put x 0, this first term will get eliminated. So here I have minus 3 by 32 into WL cube L square, it is WL square. Next minus W by 2. Now x, if I put 0, here I have minus L by 4 square, so that becomes L square by 16. L square by 16. Then here we have minus W by 2. X, if it is 0, here we have minus 3L, so 3 square, that becomes 9 L square by 4, that will be 4 square, that is 16. So therefore dy by dx at A is equal to 1 upon EI. Here we have minus 3WL square by 32 minus WL square by 2 into 16, that is 32, minus 9WL square upon 2 into 16, that is 32. So on further simplification, dy by dx at A will be 1 upon EI. 32, I can take it common in the denominator, so minus 3 WL square minus WL square minus 9 WL square. So here we have minus 3 minus 1 minus 9. So that is, if I add the terms here, 3, 1, 4 and 9, that becomes 13. So here we have minus 13 as the answer. So therefore dy by dx, that is the maximum slope at A, is equal to minus 13 WL square upon 32 EI. That is the answer which I am getting. So therefore this is the maximum slope which will be acting at point A. Answer number 1. Similarly, the maximum slope will be at x is equal to L, that is at point B. There also we will get the value of maximum slope. So next is, I'll keep x is equal to L. So therefore after reaching here, put x is equal to L in equation number 3. So we have, I'll keep dy by dx on one side, at B we have to find out, and here I'm shifting EI onto the other side. So 1 upon EI. Now W, instead of x I'll put L, so WL square by 2 minus 3WL square by 32 minus W by 2. Now here we have L I'll put this L minus L by 4 square minus W by 2, L minus 3L by 4 square. So therefore, on simplifying this, 1 upon EI, here we have WL square by 2 minus 3 WL square by 32. Now if I simplify this bracket, here we have 4L minus L, which is 3L by 4. So 3L by 4 square it is. So that becomes 9L square by 16. So here we have, from this it will be 9L square by 16. So into 9L square by 16. So now here I have written the value of this bracket, and outside this bracket we have W by 2. So this is minus W by 2, and here we have minus W by 2 again. Simplifying this, here this will be 4L minus 3L, which is L by 4 square. So that becomes L square by 16. So here I have L square by 16. Therefore dy by dx at B is equal to 1 upon EI. Here we have, the first term was WL square by 2, which is here, minus 3 WL square by 32, minus this will be 9 WL square upon 2 into 16, 32, minus WL square upon 2 into 16, 32. So on simplifying this, here I can take 32 as the LCM. So I'll have to multiply with 16 here. So numerator will also get multiplied by 16. So 16 WL square minus 3 WL square minus 9 and minus 1. So on simplifying this, here we have 16 minus 3 minus 9 minus 1. So that becomes 3. So dy by dx at B is equal to 3. This complete term is 3 WL square upon 32 EI. So this is my second answer. That is, I have found out the maximum slope at point B. Answer number second. Now, after getting the slope at point B, the next question was to find out the maximum slope and deflection. See, we have found out the maximum slope. Now maximum deflection. Maximum deflection will be at the location of the load. So here I'll say that for the maximum deflection, here, since under the action of the load the beam is bending, so I'll calculate 3 deflection values. That is, first at L by 4, and next at, I'll take the half location, that is at L by 2, and see the which value is greater. So for that I will require the deflection equation, and we were having deflection equation in equation number second. So here we have, in equation second we are having the deflection equation. Just we need to put the values of C1 and C2. So therefore put C1 and C2 in equation number second. So we have EI into Y is equal to, first is Wx cube by 6, that will remain as it is, plus C1 into X. Now C1 was, we have found out previously, it was minus 3 by 32, that into WL square, So minus 3 by 32 WL square. I'll put the value. This is C1 into x plus C2 was 0, so no need to write the value here. I'll write the next, copy these terms as it is. Now after this I can say that equation number 4 gives us the deflection equation because there is y. So therefore equation number 4 gives the deflection equation, and from equation number 4, deflection at any given location in the beam can be calculated. So with the help of this equation we can find deflection at any given location. Now first I'll calculate the deflection where the load is acting, that is at L/4 distance, which was clear from the diagram given. So first I'll find the deflection at L/4 because at A and B the deflections are 0. So therefore at x is equal to L/4 distance. So put this value, put x is equal to L/4 in equation number 4. So now if I put the values, y I will keep it as it is, and this we are calculating at L/4 distance. EI I'll send it here, it gets multiplied on the left hand side, so on right hand side it would be divided. W by 6 I'll keep it as it is. X cube, so here we have L/4 cube minus 3 by 32 WL square into x is L/4 minus W by 6 L/4 minus L/4, this term will finally get eliminated, minus W by 6 L/4 minus 3 L/4 cube. So I'll have to simplify the terms here. So therefore y, that is at L/4, is equal to 1 upon EI will remain as it is. Then we have W by 6 into, here we have L cube by 4 cube, so L cube divided by 4 cube, that comes out to be 64, minus 3 by 32 W L cube, we have this as WL cube, so 32 into 4, that gives us 128. So here I can directly write this as 128, then minus W by 6, and this term, second term, this would be directly equal to 0 because plus L/4 minus L/4 gets cancelled, so it is 0. So I am writing minus W by 6 and simplifying this term. So here we have this as 4L. Here if I can simplify this, that will become denominator, here we have 4, so L minus 3L, that will be minus 2L by 4, so that becomes minus, here this will be minus L by 2, and we are having cube of this term, so that becomes minus L cube upon 8. So instead of this complete bracket, I can write that as minus L cube by 8. So again simplifying this, Therefore y at x is equal to L by 4, that will be 1 upon EI. This, if I multiply this 64 into 6, that would be 384. It comes out to be 384. WL cube is in the numerator, minus 3 WL cube upon 128. Here we have minus into minus, that becomes plus WL cube upon 6 into 8, that is 48. So on further simplification, y at L by 4 comes out to be 1 upon EI. Here I'll take 384 into the denominator part. So here I have WL cube. Next, this is 128. So I have to multiply by 3 to make it 384. So 3 gets multiplied in the numerator. So minus 9 WL cube plus 48 to make it 384. I have to multiply by 8 in the numerator denominator. So 8 into WL cube. So now here I am getting y at L by 4 distance. That comes out to be, if I simplify this term, that will be 0. So it means here I am not getting the maximum deflection. So for that I'll have to keep another value, and that is at L by 2 distance. So I'll say that therefore put x is equal to L by 2 in equation number 4. So here we have EI into y, that is, it is equal to, in equation 4 I am keeping the value, W by 6 will remain as it is. It is x cube, so L by 2 cube minus this term 3 WL square by 32. X is L by 2 minus W by 6. X is L by 2 here minus L by 4 cube minus W by 6. X L by 2 minus 3L by 4 cube. So here what I'll do, I'll keep y on one side, and this is at x is equal to L by 2. Shifting EI, here it is getting multiplied, so if I shift on the right hand side, it becomes divided. So 1 upon EI into the bracket. Here I will be having W by 6 as it is. This will be L cube upon 8 minus, here we have, this term will be minus 3 WL cube upon 32 into 2, that is 64, minus W by 6. Now this term, here we have 4L, this is 4L minus 2L, that is 2L upon 8. So 2L upon 8, 4L minus 2L, that is 2L upon 8. So that will be L by 4. So L by 4, it is cube. So it is L cube upon 4 cube. L cube upon 4 cube is 64 minus W by 6 into, then here we have 4L minus 6L. So 4L minus 3 to the 6, 6L upon 2 into 4, that is 8. So that is minus 2L by 8, and it is cube. So that becomes minus 8L cube upon 8 cube, that comes out to be 512. So here I am having the value of this as minus 8L cube upon 512. So therefore 1 upon EI Now if I go on simplifying this, here we will be having WL cube by 48 minus 3WL cube by 64 minus WL cube upon 384 minus, this will be minus into minus, that will be plus 8WL cube upon 512 into 6, that is 3072. Next, after reaching here, when we would be simplifying this, y at x is equal to L by 2, that would be, I'll first take this as the LCM, which is 3072. Outside the bracket we have 1 upon EI. So here this 48, to make it 3072, multiply by 64. Similarly in the numerator, next here I have 64, so here this will be minus 3 into 48, that is 144 WL cube minus 8 WL cube plus 8 WL cube. So from this, if I go on simplifying, I'll get my answer as, therefore y at x is equal to L by 2, that will be, here I am getting at x is equal to L by 2 the value of y after simplifying the terms here. It is minus 80 WL cube upon 3072 EI. So this is the maximum deflection, our third answer. And if we look into the problem, the question was to find the maximum slope and deflection, and we have found out the maximum slope and deflection for the beam which was simply supported carrying 2-point loads at distance L by 4 and L by 4 from both the supports. And once we have calculated the maximum slope and deflection, we can say that the problem is completed.